In this video, we'll get a better understanding of the different types of cameras and their uses in Unity. In some regards, a 3D camera can be viewed conceptually like a real camera. To set up your shot, you need to position the camera properly and rotate it so it's pointing at what you want to see. But the similarities stop there. With a traditional lens camera, light passes through the lens, projected onto a flat piece of photosensitive film or CCD. You can focus the lens for depth of field effects. There are different glass lenses for different effects, such as telephoto, wide angle, fisheye, and so on. In a game engine, the camera is really just a projection of 3D geometry onto the 2D plane of the display. You can simulate lens effects like focus, lens flare, and fisheye, but it is processor intensive, and it is artificial. However, we have gotten pretty good at making the artificial look realistic. There are two types of 3D projections you can create within your games: perspective and orthographic. The perspective projection is most like a real camera, or how we see the world. This is used commonly in first-person or third-person games. Objects that are closer to the camera are larger than the same sized objects that are farther away from the camera. Orthographic projections do not really exist in the real world. The computer maintains the same relative size of the object, no matter how close or far away it is from the camera. Common uses of orthographic projections is for top-down or isometric views on games. The view frustum determines what is rendered to the display. The perspective camera has a pyramid view frustum, with a narrow field of view close to the camera and a wider field of view farther away from the camera. As an object moves closer to the camera, it will appear larger or closer. The camera renders everything between the near clipping plane and the far clipping plane. If objects move closer than the near clipping plane, they will not be rendered. If they move farther away from the far clipping plane, they will not be rendered as well. The orthographic camera has a rectangular view frustum with a constant field of view or orthographic size throughout. Objects, no matter where they are in front of the camera, will appear the same relative size. The same concepts of near and far clipping planes apply to the orthographic camera as they do to the perspective camera. Our objectives in our project are to understand some of the camera settings, make the perspective camera controllable, and add a mini-map through the use of a second orthographic camera. Okay, as we mentioned previously, in our scene, we have the main camera. The main camera is a special kind of camera. It's the main one that we're viewing. Typically, it's what you see in the game view down here. Notice the main camera is tagged as main camera in the inspector. By being tagged as main camera, Unity can always identify this as the main camera, and you could refer to it, for example, in code. And just like any other game object, cameras have a transform component. And right now our game camera is at 0, 0, -10. So if I kind of zoom out here using my mouse scroll wheel, we can see it's right there. We can tap F to zoom to that. And part of the reason our solar system looks kind of small here is because the camera is 10 meters away. So a simple thing we could do here in the top-down view is grab the Z-axis and just move it a little bit closer, and you can see the camera comes in, and there we go. I've got my camera at -3.46. I can go ahead and just edit that if I want it like -3.5 to make it precise. And if I press play now, you can see a lot better, the Earth coming by here, and the moon and the sun and so forth. Once again, we can play with our lighting now. If this is kind of the position that we want our camera, we could turn up our lights if we think it's too dark. Once again, you can play with these things, the directional light. I could turn up the intensity, for example, to make it a little more intense or less intense. And once again, as I'm playing with these, it's not going to stick when I stop, so I would either have to copy that out. Kind of a little shortcut here is you can take the component, click the ... go down and say copy component, and then when I stop, it's going to reset back, and then I can click the ... again, and then say paste component values. So that pastes the values of the component that were just copied. But now that I'm in edit mode, it's going to stick. So let me go back to the main camera since that's what we're talking about primarily. A few other settings here, as you can see, the field of view. The default perspective field of view is 60. You can adjust this, so notice what happens if I do a bigger field of view. And you can see, up here in the scene view, if I zoom that, you can see here's the sort of frustum that comes out, the triangle, the pyramid. So that's going to make it wider, kind of like a wide angle lens. And if I come back in and go narrower, it's kind of like it's zooming in, but it's just a narrower field of view. So once again, I'll go back to the default, which is 60. Another thing to notice is the near and far clipping plane settings here. So these are, once again, are in meters. So it's going to be 0.3 meters is the near clipping plane. And if I just, click and make this, much bigger, you can see the clipping plane there in the scene view. And if I go far enough, it's going to make the sun and everything disappear. So once again, I'll go back to 0.3. And then the far clipping plane is 1,000 meters. If I bring this down to something much smaller, like 10, you're going to see that far clipping plane here. And this might be totally sufficient for our solar system model because maybe nothing is going to go 10 meters out, from the sun. So there's no reason to try to render stuff all the way out to 1,000 meters. And this is one way to optimize performance, is to set your near and far clipping plane smaller, so you're only rendering what's in the view frustum. Now, we've been working in a top-down view within our scene, but if we wanted to make our scene view look like our game view, for editing purposes, you could just click on the main camera, and then under Game Object, you can select Align View with Selected. So Align View with Selected, and it's going to make my scene view very much like my game view. The main difference is I don't have the same field of view, but I can zoom in here to basically replicate what I'm seeing in the game view. Okay, we have our main camera set up. Once again, you can click the little question mark to see all these different properties, what they mean in the documentation, and you can play with those things and kind of see the effects. But let's now create another camera. So I want to actually make a mini map, and an easy way of making a mini map is just making a second camera looking at the world in a different way. So let me go ahead and hit the little plus here and go down, and we want to create a new camera. So there we've got a second camera in our world. Notice we're still seeing the main camera here in our game view because that's the default camera. And also notice our new camera is not tagged as main camera. It's just untagged currently. And I'm going to rename my camera as Minimap Camera. Now, cameras always have audio listeners, and we're going to talk about this in the next video, but audio listeners, there should only be one audio listener at a time. So our main camera has an audio listener, and the Minimap has an audio listener. So let me just disable the audio listener on the Minimap by turning the audio listener component off for the Minimap. Now, this camera defaulted as a perspective camera, but we're going to go ahead and change the projection type to orthographic to kind of see what an orthographic camera is like. So we can see the orthographic view down here. And one of the properties of the orthographic is the size. Right now it's set to 5. Let me just change that and set it to something like 4 to make it, a little bit closer. And, if I go down to 3, it's going to make it even a little bit closer. Now, if I switch to a top-down view on the and look at the camera here, you can kind of see, rather than the pyramid view frustum, we've got basically the box here coming out. And just like the other camera, I can modify my clipping plane to something like 10 meters. Now, currently the Minimap camera is positioned basically the same place as the main camera. So you can see they're both positioned at 0, 0, negative 3.5. Now, I want the Minimap camera to be a top-down view of the world. So a quick way to do that is, let me go to the center of the world by selecting the sun and then tapping F. So I zoomed into the 0, 0, 0, right where the sun is. And then let me make sure that I'm in a top-down view of the world, which I am. because I just switched to that. So let me zoom back out here a little bit, and let me select the minimap now. And previously we chose under game object, we chose align view to selected, which aligned our scene view to, you know, the position of the game object. But this time I'm going to say align with view, which is sort of the opposite. So what that means is it's going to change the minimap camera's position to the position of my scene view, if that makes sense. So let me select it, and you'll see kind of what happens here. The position of my camera changed to 0, and then 5.2 blah blah blah, and then basically 0 here. It's sort of the super small number, and it looks really weird. So I'm going to clean this up a little bit. Let me say I want to be 5 meters above, and I want to be 0 in the Z direction. So I'm 0 0, and I'm just above. And with the camera selected, I can hit the Alt key and rotate around and kind of see what's going on with that camera. It's pointing down and right at the sun there, and you can see the Earth and the moon. So that's kind of the position of that camera. And then here's the other camera, which is the main camera, which is projecting out that way. Now, I actually misspoke previously. We're actually here in the game view, we are actually seeing the minimap camera. And that is defined by the depth of the camera. So you can see that the depth of the main camera is set to -1. And you can see the little tooltip here says a camera with a larger depth is drawn on top of the camera with a smaller depth. So if I look at the minimap camera, its depth is set to 0, so 1 higher than -1. And if I change this to like -2, you can see now our game view is showing the main camera. If I set this, back to 0, we're now seeing the minimap camera. And we actually do want the minimap camera to be on top because we want to see the minimap on top, and then behind that we want to see the main camera. So basically what we need to do is we need to make the minimap camera smaller. And the way we do that is through the viewport rectangle, or the viewport rect. So these properties are sort of the X and Y location and the width and the height. We're not going to change the X and the Y location, but we are going to change the width and the height. So I'm going to change the width of my camera to 0.25, which means 25% basically of the width of the overall game. And you can see now I've got one camera here and the other camera here. And let me change my height also to 0.25, and you can see it right down there in the corner. So the 0 0 position of X and Y basically bases it off of this bottom corner here. If you want to move it around, you would change the X and Y. So now if I actually hit play, you're going to see my main camera here. This is the kind of front view of the world. And then you see my top-down camera here, where you can see the Earth and the moon, from the top down rotating around the sun. Let me go ahead and press stop. And of course you can adjust the positions of the cameras and the field of view for the perspective camera, or the size for the minimap if you don't like the direct things that you're seeing within those views. The last thing that I want to do for my minimap camera, just to make it set it visually apart from the main camera, is to change the clear flags property. So notice the clear flags property says skybox, which basically means the camera is going to render the skybox kind of in the background. So if I change this to solid color rather than skybox, it is then going to render this background color. So you can see now clearly this is a different camera. And of course you can change the color. If I choose that, I've got my color picker, and I could just make it maybe a slightly darker blue or something like that for purposes of example. So if I press play now, you can see once again our main camera with the skybox, and we can see our minimap with the solid color background. And let me hit stop. Okay, the last thing that I want to do is I want to make my main camera controllable. So we actually included one other script in our project. It's the look at target script, and we can go ahead and attach this as a component of the main camera. So let me drag and drop it here on the main camera, and you can see it's got two properties it's requesting: the default target and the current target. So the default target is the sun. That's what we want to look at initially. So I can hit the little target here and choose the sun for that. And then the current target is what is currently the target. So I'm going to make the current target the sun. So they're both the same at the beginning of playing. Okay, with that set, let me go ahead and hit play, and I'll kind of show you how this works. So as it's playing, it's looking at the sun. You can see over here in the inspector, sun, sun. If I click on the Earth though, now I'm looking at the Earth. So the current target is the Earth. And if I'm skilled enough, I can click on the moon. There, now my current target is the moon, and the camera is basically tracking the moon. So you can see up here what's happening in the scene view. The camera is actually rotating to look at whatever the current target is. There, let me look at the Earth again. And it's tracking that. So the camera isn't actually moving, it's just changing rotation to always look at. So the Z-axis is always pointing at whatever the current target is. And the script is set up so, left clicking sets the target. If I right click, it goes back to the default. So that's kind of, if you click on something weird, if you've got a whole bunch of planets or something and it's a little bit crazy what's happening, you can right click and it will just jump back to the sun. Or of course, if I can see the sun, I can always just click on the sun. So now our camera is a little bit controllable. Let me go ahead and hit stop. Okay, we've got two cameras set up now. We've got the main camera positioned properly and we've got it controllable. And then we've got our mini map, which is a different view on our world, a top-down view, and we placed it right down here in the corner. So just to finish up this video, I'm going to go ahead and do File, Save Scene.